I'm Benedetta Liberatori, and I will present our work, Test Time, Zero-Shot Temporal Action Localization. We address the task of temporal action localization, consisting of localizing and classifying actions in untrimmed videos. Given a video, the model should jointly output when an action starts and when it ends, together with the action class label. There can be multiple occurrences within the same video. Specifically, we tackle the zero-shot setting where the action class labels are unknown at training time. Previous works train a model in a supervised fashion and test it in domain on classes unseen at training time. This has two main disadvantages. First, they require a large annotated video data collection. Then, as shown in our cross-dataset experiment, they poorly generalize out of distribution, despite being trained to improve their zero-shot capabilities. Indeed, here we can see the performance of state-of-the-art models when tested in domain, and the same models tested on a different dataset. Motivated by these findings, we tackle a more practical scenario where the training data is not available. Specifically, our method works at inference time, only exploiting a single test video at a time. Our proposed method, T3AL, is built on top of a pre-trained vision and language model consisting of an image and a text encoder. We employ COCA as the VLM. First, a compact visual representation of the video is used to predict a video pseudo-label by a cosine similarity. Then, we perform test time adaptation to update the predictions of the model with self-supervision, optimizing only the parameters of the projectors of the two encoders. We score frames with respect to the semantic closeness to the pseudo-label and form a set of positive and negative samples from closer and more distant embeddings. Our objective consists in a representation loss that brings the embeddings of the positive sample closer in the latent space, and a separation loss that pushes the scores of positive samples toward 1 and the scores of negative samples toward 0. Both are implemented with a Biot loss, which is commonly utilized in self-supervised learning and particularly in scenarios lacking negative samples. At the end, we compute a moving average of the scores to further enhance temporal consistency and predict action proposals via thresholding. Then, we reinitialize the parameters of the two projections. The last steps aims to reduce potentially incorrectly predicted action proposals. From captions, we obtain textual representation of the selected regions. This can be done with the decoder of COCA, so without an external captioner. Then we calculate pairwise cosine similarity and establish a rejection criterion. Specifically, a proposal is discarded if its associated textual representation is insufficiently close to the others. We compare our proposed method with training-based state-of-the-art models and training-free baselines on two benchmarks, TOMOS and ActivityNet, in terms of mean average precision. In particular, we show that a naive application of VLMs is insufficient, that our training-free baseline already achieves significant improvement over the VLM-based baselines, and that with test-time learning we improve further. Here we can see some qualitative results of T3AL, and you can refer to the project website for more details. To validate the potential of our proposed methodology, we conduct an oracle experiment. Starting from our method design, we identify three components we can replace with oracle information. First, we use a perfect classifier, replacing the video pseudo-label with a perfect prediction. Then, we re-evaluate the performance of our suppression strategy when we select the exact number of actions region present in the video. Last, we consider the scenario where we retrieve positive samples from intervals encapsulating the video level pseudo-label and retrieve negative samples from outside such intervals. This consists in a considerable gain in performance with respect to the previous oracles. With the combination of the oracles, we match state-of-the-art training-based results, and this analysis investigates the potential of the proposed approach and partially highlights that annotated training data is not fundamental. In conclusion, we highlight a shortcoming in current zero-shot temporal action localization methods, proposing a cross-dataset experiment. We propose T3AL, adapting an image-based VLM at test time, and we show that test time adaptation is a promising direction to calibrate VLMs to solve tasks in untrimmed videos.